Welcome, dear learners. So, today we are going to talk about simple compounds. Let's start by looking at the objectives of this lesson. So, there are three main things that I need you to know by the end of the lesson. Number one, you should be able to use the symbols of the element and write the formula of simple compounds found in the syllabus. So, you should be able to identify those simple compounds that you have found in a syllabus. We're not going to do all of them today, but then you should be able in a position to work with them. Deduce formula of simple compounds from relative numbers of atoms. So that's another thing. So using the number of atoms to deduce their formula, and lastly to determine the formula of ionic compounds from the charges of the ions present. So we shall look at these three main objectives today. So let us get started. So let's start by looking at elements of symbols. Symbols of elements. Let's look at symbols of elements. Each element is represented by its own unique symbol as seen on the periodic table. So, for example, we have hydrogen in the periodic table. We have different elements. We have magnesium, we have sodium, we have iron, we have copper, we have cobalt. So, a lot of elements that are found in the periodic table. So, we use a certain symbol to represent those elements. Where a symbol contains two letters, the first one is always a capital letter, and then the second one is always a small letter. So please note that. For example, if we're talking about sodium, so it's going to be Na. So N, the capital letter, and then A is a small letter. So we do not write it this way. We do not write Na both capital letters. So here is a periodic table. So you can look at the periodic table yourself. So you can see the periodic table contains different elements. So we're starting with hydrogen. We have helium here, and we have lithium and so forth. So you continue. So you make sure that you familiarize yourself with those elements that are commonly used in our syllabus. Okay. So atoms combine together in fixed ratios that will give them full outer shells of electrons. So we are going to look at these fixed ratios in which atoms combine so that at the end of the day they have a full outer shell of electrons. Then we've said those atoms have combined. So the chemical formula tells you the ratio of atoms. So for example, let's look at water. So water H2O is a compound containing two hydrogen atoms which combine with one oxygen atom. So if we have H2, so that tells us that there are two atoms of hydrogen, and then oxygen, it tells us there's one atom of oxygen. So we call that water. All right, so the chemical formula that can be deduced from a relative number of atoms present. If a molecule contains three atoms of hydrogen and one atom of nitrogen, then the formula is going to be NH3. NH3. So the diagrams or model can also be used to represent the chemical formula for like this one. So we have nitrogen combining with hydrogen, hydrogen, and hydrogen. So at the end of the day, we have nitrogen, and then we have three hydrogens. So there are three atoms. Yes, there are three atoms of hydrogen. So then we write the formula like this one. So as to which one comes first, because we cannot write it like this. As to which one comes first, so we are going to learn how do we decide which one should come first. So For example, even in water, so it's H2O. We can write OH2. So we are going to learn as to which one is supposed to be is supposed to come first here, because we are going to look at actually you can revisit your notes on bonding. So because we have to look at covalent bonds and ionic bonds. Okay, so we do not write it this way, so I need to erase this one. So this one is not correct. Right, so we write it in this format. So we let's talk about chemical formula. uh, Chemical formula, we can represent it in different forms when we are representing a chemical formula of a certain compound. So we have a structural formula which tells the way those atoms have combined or have bonded in the molecule. So yeah, this can be done by either a diagram or a displayed formula, or can be we can use a written simplified structural formula. So we can use a diagram or we can use the symbols, which is the simplified structural formula. So we still call them both structural formula. So let's look at as an example. We are going to look at an example of those structural formula. So, and then we also have an empirical formula. Empirical formula, we are going to learn more about empirical formulas as we continue in the next videos. But for now, you should know that empirical formula, it just tells you the simplest whole number ratio of atoms. It tells you the simplest whole number ratio of atoms in a compound. So that is the empirical formula. It's basically is the simplest whole number ratio. And then the molecular formula, it tells you the actual number of atoms. You see, the empirical is simplified, and the molecular formula tells you the actual number of atoms in of each element in one molecule of the compound. So now, for example, if we have hydrogen, so normal hydrogen appears as diatomic. So we in this way, so the hydrogen, if it's H2, then it tells us that hydrogen has got two atoms here, and here we have hydrogen chloride, or we have hydrochloric acid, hydrogen chloride. So we have one hydrogen, and we also have one chloride or chlorine. We also have one atom of chlorine. So that is how we decide that is how the molecular formula tells us the actual number of atoms. So even if you have suppose you have uh, we are combining, let's see, you remember when we were looking at um, uh, bonding. So suppose we want to combine sodium, and we combine sodium and maybe with oxygen. All right, so we remember that sodium is in group 1, so we have one, and then we have oxygen we is in group 6, so it means oxygen needs two electrons in the outer shell to make it stable. So it is going to be 2 minus. Okay, so now you see this one, when we are combining these, so we will have how many we will need two, because let's throw oxygen, so it's one. Unfortunately, I'm unable to throw here, my pen doesn't allow me to throw. But this one, we are going to have nitrogen oxide like this, because we need two atoms of nitrogen, and then we need one atom of oxygen. So this two tells us how many atoms of this element do we have, and here we have one, but we do not write that one. So it tells us that we have one atom of of what? We have one atom of of oxygen. All right, if we have a sulfate like this one, so this tells us that we have one atom of sulfur, and then we have 4 atoms of oxygen. Okay, so then those small number tells us the number of atoms. So let's look at another example. Let's look at butane. Butane, we talked about structural formula, empirical formula, and then we also talked about the molecular formula. So let's look at the structural formula of butane. So this is how butane combines. So here we have 4 carbons, just like you see, and then we have this carbon combines with 3 hydrogen plus this other carbon, and then this one, you see how it combines. So this is a structure or a structural formula of butane. So we can display this is displayed, and we can write this or simplify this structural formula of butane. So you see we have a simplified formula of butane now. So this one is C, this C, the first C, it combines with how many hydrogens? 3. 1 2 1 2 3. All right. So and then we also have the other carbon. It combines with 2 hydrogen, and so forth. We continue to this one, it combines with 2, to this one it combines with 3. Then we are going to come up with this structural formula simplified uh, of butane. So this one and this one, actually they're just the same. It's just that here we've simplified here, and here we've displayed it. Then we also have a molecular formula. So remember, we said the molecular formula, it tells you the actual number of atoms in the molecule. It tells you the actual number of atoms in the molecule. So here we have a molecule of butane, which has got 4 atoms. 1 2 3 4. It has got 4 atoms of carbon. So then we write C4, and then it has got how many hydrogens? It has got 10. So which is 1 2 3 4 5 6 7 8 9 10, and then we write 10. So it has got 10 atoms of what? Of hydrogen. So we can also write this in using empirical formula. So empirical formula here is a simplified ratio. We say this one is a simplified what is this ratio? So when we talk about empirical formula, so here we have the ratio 4:10. So which is the original ratio? 4:10. Oh, sorry. 4:10. Sorry for that. 4:10. So now what is happening here is that we are simplifying 4:10. So we look for a common factor, which is 2. 2 here goes into 4, goes 2 times. So we write 2 into 10, it goes 5 times. So we know that this 4 was for carbon, and then the 10 was for hydrogen. So now it means we are going to have C2H5. So that one is a empirical formula. Okay. So deducing a formula by combining powers. So the concept of valency, which is used to deduce the formula of compound. So this is we want to use this concept of valency of atoms to use. We use this concept to deduce the formula of a compound. Valency or combining power tells you how many bonds an atom can make with another atom. So let's look at the examples. We are going to look at examples. So e.g., if we have carbon is in group 4. So a single carbon atom can make 4 single bonds or 2 double bonds. So remember, carbon, if it is in group 4, it can make 4 single bonds, or it can make 2 double bonds. So the following valences apply to element in each group. So now let's look at this one. So for those elements which are in group 1, so which include lithium, even hydrogen, sodium, and potassium. So those ones, they have the valence of 1. It means they can donate 1, because these are metals, so they can donate 1 electron, or which is, this is their combining power. Okay, so they can make 1 single bond. Okay, and then we have those elements which are in group 2, which include magnesium, calcium, and calcium. So those ones have got a combining power of 2 electrons. So they can make 2 single bonds, or they can make 1 double bond. So that is if it's doable like that. So, and then group 3, so those include boron and aluminium. So I'm just naming the common elements that we use. So otherwise there are a lot. So you can look at your periodic table to find these elements. So those ones have got a combining power of 3. Group 4 have got a combining power of 4, which means they can make 2 double bonds, or they can make 4 single bonds. So you remember when we talked about bonding. And then group 5, it is 3, in group 6 2, group 7 1, and then group 8 do not have a combining power. So that's why they are unreactive, because they do not have the combining power. So those ones. All right. So we can use the combining power of each atom to work out a formula. So let's look at an example of aluminum sulfide. So we are looking at an example of aluminum sulfide. How we can use the combining power. Now, write out the symbol of each element and write their combining powers underneath. So here we have an example. So we have aluminium. Aluminium is in group 3. So we know that elements which are in group 3 have a combining power of 3. So we write 3 underneath aluminium. Then we have sulfur, sulfur is in group uh, 6. So for those which are in group 6, their combining power is 2. Okay, so now what does this mean? So we have sulfur, and underneath sulfur we have 2. So how can we use this now to find the formula of the compounds aluminum sulfide? So this is how we do it. So here, so this is the same thing that we've just talked about. So the formula is then calculated by cross multiplying each atom with the number opposite, hence the formula for aluminum sulfate. So now we cross multiply. So here it means you take this 2 and comes here, and this 3, it comes here. So that is how we cross multiply. So we are going to have aluminum 2, because we are taking the 2 from which was underneath sulfur, and then we have sulfur 3. So now that is how we get the formula of aluminum sulfide. So this one is the the chemical formula of aluminum sulfide. Okay. So we can maybe let's just take another example. So I was doing sodium oxide. So we have sodium, all right, and then we have oxygen, which is oxide. So now sodium, the combining power of sodium is in group 1. The combining power of sodium is 1, and then oxygen is in group 6, which means the combining power of oxygen is 2, because it needs 2 electrons to complete its outer shell. So now what we do, we cross multiply. We take this one here and we bring this 2 here. So now we are going to have sodium 2 oxide. So this is going to this is the formula for sodium oxide. So we just write it like that. So this one is when we are we want to find the chemical formula of substances. Okay, So right, so deducing formula of ionic compounds. Now you remember when we talk about ionic compounds, we are talking about metals. Actually, we have looked at the metals plus non-metals. So these are ionic compounds, metals plus non-metals. So the formula of this compound can be calculated if you know the charge on the ions. Below are some common ions and their charges. So it is easier to find the charges of those elements which are falling in the groups, group 1 up to group 8. But for those which are the transition elements, so you remember the transition elements in the periodic table, so those are the ones that we want to look at now. Here, so these are just common. I will show others later, still in the same video, but here let's just look at these few ions. So we have an ion 2. Ion 2 is an ion of ion 2. So this is how we this is the charge of that ion 2 ion, which is ion 2 plus. So we also have ion 3, which is going to be ion 3 plus. We have copper 2, so we get this is an ion of copper 2, so we are going to get copper 2 plus if we want to write the formula and the charge. Chromium 3, so it's chromium 3 plus. Ammonium, so this is the charge of ammonium, and the formula of ammonium is NH4 plus. And then hydroxide is OH minus. Nitrate, so you should know these ones. You should be able to memorize all these. Nitrate, it's OH minus, sorry, NO3 minus, so the charge of nitrate is minus. And then sulfate, it's SO4 2 minus. Carbonate, so now what you should note is that some have got a charge 1, some have got a charge 2, and some have got a charge 3. So it can be 1 plus. So for example, which one is 1 plus here? Or we don't have an example which one is 1 plus here. Some can have 2 plus, like iron 2. What else? And copper 2. Some have got 2 minus. 2 minus. So those ones, you can see those are those that have combined non-metals and non-metals. So we have two. So we have sulfate, we have carbonate. So they've got 2 minus, and then some have got 3. Could be 3 plus or 3 minus. So 3 plus, here we have an example of chromium 3, and then we have 3 minus. We don't have an example of 3 minus here. Okay, so we shall look at them in the others. So they are not very common. So we should know even the formula. For example, we should know that the formula of carbonate is CO3. So this is the formula of carbonate is CO3. Now, but then if we want to include the charge, because we are going to need the charge if we want to derive the formula of this. So we are going to get what now? The charge is 2 minus. All right. So that's the formula of carbonate and its charge. So please make sure that you memorize all these ones, and even the other ones that I'm still going to show you in the same video. Right, so now we can use these to find a formula of an ionic substance. So what we need to know is that for an ionic compound, you have to balance the charge partly by for ionic compound, you have to balance the charge of each part by multiplying each ion until the sum is of the charge equals 0. So let's explain what we mean by that. So let's look at this one. Example, what is the formula of aluminum sulfate? All right. So we are going to write out the formula of each ion, including their charges. So we have aluminum. So aluminum, we know that aluminum falls in the groups. So then its charge, charge of aluminum ion is 3. Okay, so we have aluminum 3 plus. All right, just like this. Okay, so I'm just writing so that you are able to see clearly. And then we have sulfate. So you see here, let's go back here. So we have the formula and charge of sulfate. It's SO4 2 minus. So now let's write that one. So we have SO4 and then this is the charge. So this is an ion, SO4 sulfate. It's an sulfate ion, which has got more than one atom types of elements. So it has got sulfur and oxygen. All right, so 2 minus. All right, now what is the next thing that we do? We balance the charges by multiplying them out. Okay, so let's go back to this one. We multiply them out. What we need to do here, aluminium, we said it's times aluminium 3. So let's take this one, aluminium 3. So we can say 3 times 2. We use this 2. 3 times 2, what are we going to get? So this is plus 3. We are going to get plus 6. And then here we have negative 2 times 3. What do we get? We get minus 6. So now if we say plus 6 plus minus 6, we're going to get 0. We're going to get 0. So now you remember here we said we multiply until the sum is 0. So now this is how we get 0. So this one, aluminium, it was a plus 3 ion. So we multiplied it by 2. So this tells us that we need 2 atoms of aluminium in this compound. So we are going to have aluminium 2, and then here we multiplied it by 3. Then what does this tell us? It tells us that we need 3 atoms, 3 ions, so yes, 3 sulfates, 3 atoms of sulfate. It's not atoms now, 3 molecules of sulfate. So that is how we are going to write it here. So we have aluminium 2, and then please note that sulfate is OSO4. So we need to put this in a bracket to show that this one is an ion which has got more than one element. So then we write 3 because we multiplied by 3 here. All right. So, and here I have another more examples of those that of the valencies, or we call it the oxidation state of atoms, or of groups of atoms. So here these ones have got a valency of 1. So here it's supposed to be 1 there. So I've got a valency of 1. So we also have those ones which have got a valence of 2. So all these ones, so we have metals, non-metals, and groups of atoms. So let's look at metals. Metals, so these are the common one. Lithium has got plus 1, which is plus, it's 1. Sodium, potassium, silver, and copper. So they all have an oxidation state of 1, or a valence of 1. That is the combining power. So these are just examples. So you can add them. You can add a lot. Okay. And then we have non-metals which have got 1. So you have fluoride, with chloride. So these are the ions, bromide ion, hydrogen ion. And then we have groups of atoms like hydroxide, which is hydrogen and oxygen. So that is how we write hydroxide is OH. So this is hydroxide. But if we want to include its power or its charge, it is got -1. All right. Nitrate. So we do not write the 1 here. So we do not write the 1 here. But we know that if we just write negative, we already have the 1. Nitrate is NO3. Please make sure that you memorize these ones. Ammonium hydrogen carbonate. It's hydrogen carbonate is hydrogen carbonate. So this is the formula for hydrogen carbonate. And then if we want to find the charge is 1. And the manganate 7. So that is the charge. So others have got, so here we can combine. So here we can combine, suppose let's take lithium, and let's take lithium chloride. So what we are going to have here, we have lithium and then we have chloride. So now we know that lithium, the charge of lithium is +1 and the charge of chloride is -1. So these ones, to get a 0, so we are going to multiply this one by 1. So we have +1, which is +1 times 1. And then here we get +1. What is this? We're going to get +1. And then here we have -1 times 1. So we have multiplied by 1. So what are we going to get here? We're going to get -1. So if we add this one and this one, what do we get? We're going to get 0. So this tells us that to combine these, so the formula, we're going to have 1, because we've used 1 and 1 lithium and 1 chloride. So here it's when we are using the charges. So then this one gives us lithium 1, lithium and chloride. So this is the formula for lithium chloride. Okay. So let's just take another example. Let me just erase this. Let me see if let me just erase this one. Okay, so let's take another example. Sorry for that. Let's take another example. So here let's take a copper, copper fluoride, or copper, and no, let's take another copper nitrate. So you see here we have copper, which is copper 1. So want to write the formula of copper 1 nitrate. So we have copper 1 nitrate. All right. So we have copper 1 nitrate. So what do we get here? Copper. So it's Cu plus. And then nitrate. So we see the formula of nitrate. It's NO3. Okay. So it's NO3 minus. All right. So now here the charges is we multiply by 1 port, because they all have the oxidative valency of 1. They all have the valence of 1. So we cannot do that again. So what we need to do here, we have, so this is the formula. We are going to get copper nitrate. So these ones have cancelled each other, because plus and minus, so we are going to get 0. So if you say +1 and this one, they're going to get 0. All right. If you say +1 plus -1, so we're going to get 0. All right. So this is the formula for copper nitrate. But now let's move on to look at those which have got the valence of 2. So we have magnesium, calcium. Magnesium has got +2, +2, calcium +2, copper 2. So you remember the side with copper 1. So you have copper 2, zinc 2 plus ion 2, so it's ion 2 plus lead, and then nonmetals oxide, which is O2, O2 minus. So these ones are negative sulfur, these are negative sulfide, carbonate, sulfate, dichromate. So I think maybe we should just remember carbonate and sulfate. Then some have got the valence of 3, aluminium 3 plus, iron. So you see iron comes in different forms. We have iron 2 plus, and we have also higher iron in 3 plus. Okay, so we do not have an example of these ones here, but we have an example where there is a group of atoms that has got 3 minus. So that one is what? Phosphate. Okay, so please, then you should be able, so if we are using these ones now, again, if it's 2, suppose let's take copper 2 and copper 2 oxide. So here let's just take copper 2, want to write copper 2 oxide. All right, so copper, so is copper 2 plus now that we're using. In the other one we're using copper 1, and then oxide, the valence of oxide here, ion, is 2, so it's 2 minus. So you see these ones, they just cancel each other. So if we multiply this one by 1, multiply this one by 1, so they just cancel each other. So it means we are not going to write these numbers because we have multiplied it by 1, and this one is multiplied it by 1. All right, so we're going to get copper 2, so it means copper oxide. So this is going to be the formula for copper oxide. But if we take one which has got a valence of 2 and another one which has got a valence of 3, then that is when we need to combine. So let's take ion 3 plus and what? Ion 3 and oxide. So let's take ion 3 oxide or ion 3 sulfide. So maybe let's take the common one, which is iron 3 oxide. So we have iron 3 oxide. We want to write the formula of this one. So what we will do here, we have iron 3. So the formula for iron 3, you see, it's iron 3, it's this one, Fe3 plus, okay? Then oxide, you remember oxide is just 2, so here it's oxide is O2 minus, O2 minus. So you see these ones now, they do not cancel each other. So now what does this mean? So for this, and for iron, for this one to equal this one, so we have to multiply so that at the end of the day we have 0. So what we're going to do here, we're going to multiply this one by 2 and this one by the charge, which is the ion 3 plus, by 2, and oxide ion by 3. So now we have this one 3 plus, which is plus 3 times 2, we get positive 6, and then this one, it is minus 2 times 3, we get what? Minus 6. So if we combine this now, then this one is going to give us 0. So the simplest thing here is just cross multiplying, basically. just like we have done it in the previous one. So just assume that this 2 comes here and this 3 comes here, so that now your formula is going to be what? Ion, and then it is 2, because I'm taking this 2. Actually, this 2, this is the, what did I do here? Yes, so it's multiplied by 2. So, and then here, the 3, it comes here. It's oxide 3. So that is how we are going to get this one. Because, oh yes, ion we multiplied by 2, and then here we multiplied by 3. So these are the numbers we are taking. But basically, you can just cross multiply like this, and then this is the formula for iron 3 oxide. So this is how you write the formula for iron 3 oxide. Okay, so I hope now you have understood the basic things that we wanted to do here. So I'm sorry, this one was a very long video.